Hey everyone, welcome back to Clutch Situation. Today I thought that I would add to my Science and Engineering of Mechanical Pencils series that I've been doing, specifically related to an aspect of the science of mechanical pencils and the engineering of mechanical pencils that is related to the primary function of a mechanical pencil. Mechanical pencils exist because there is a piece within it that grips a stick of lead that allows you to control that stick of lead and where it is in relation to the tip of the writing utensil, and therefore its use in writing things on a piece of paper. And that critical aspect of the engineering that is the most important part of a mechanical pencil is called the clutch. And what I've done here on my piece of paper is I've sort of drawn three lines inside of a circle that I'm not a perfect artist. They should be at perfect 120-degree angles compared to each other. In other words, there should be exactly a even triple split between these three lines. And the idea behind what I'm doing here is to sort of sketch out for you what this internal part of the mechanical pencil called the clutch is, where it's located within the pencil, and what it does, because it is the most important part of a mechanical pencil. That's why my channel is called Clutch Situation. It is not just a play on words. It is referring to a particular part of the internal mechanism of a mechanical pencil that allows that mechanical pencil to grip the lead. And so what I'm going to do is I'm going to shade in these three different pieces so that we can sort of see what parts would be metal or plastic. In other words, what are the parts that are actually gripping the mechanical pencil? And I am not an artist, so bear with me. I'm just trying to do my best to illustrate this with you. And so this is one tooth or one piece of the clutch that I've just sketched right here. And then here is another piece of the clutch. And I'm trying to create some separation here so you can see that these are three distinct pieces. And I apologize to those of you who are using headphones. I do have to sit kind of to the right of the setup. And so if you're only getting one thing in one earphone, I don't really have the capability of seeing what I'm doing very well while still maintaining a even distribution between the two parts. And so right now I'm looking straight down the camera and that improves the audio, but then I can't really see what I'm doing. So here are the three parts of the clutch, and this outer wall would be the outer part of your pencil. And so we are essentially looking down the mechanical pencil. Okay, so the clutch would be inside the mechanical pencil. In fact, let me unscrew this zebra hand fit so I can show you where the clutch would be inside this pencil. This is a pencil that I got when I was at Tokyo Pen Shop, and I'm showcasing it in comparison with another mechanical pencil because I want you to be able to understand what the internals of these pencils are all like. And so the clutch is that brass piece that you can see, sort of a goldish color inside the green pencil. So the zebra hand fit has a brass clutch. There are a lot of other pencils, like for example, I will feature the Papermate Clearpoint, which is a ubiquitous mechanical pencil that you can buy in virtually any big box store here in the United States, that has a plastic clutch. And what is the key difference between something that has a brass clutch and something that has a plastic clutch? And I keep talking on the channel about how brass clutches are better, brass clutches are better. What do I mean by that? Well, we sort of have to get down to what the purpose of the clutch is to begin with, and what are some of the issues that can happen with the clutch, and how do different materials affect those particular issues. So the clutch of the mechanical pencil will hold the lead where I'm drawing this circle in the center of this diagram right here. So that's where the lead would be held in three little tooth positions by this three-part clutch. And that's what allows you to control how much lead is extended from the pencil and what separates a mechanical pencil from a regular wood case pencil. Most mechanical pencils are gravity feed, and the clutch is a part of that, in that when you hold a mechanical pencil upside down and try to click, I got a little bit of lead coming out of there, but as I continue to click, there's no more lead coming out of this pencil. A gravity feed means that when you're holding the pencil so that the tip is facing down, gravity does the work of allowing the lead to lower. And so when I knock the top, as it's called, or click the top, the clutch opens up, and when I unclick, it closes. So opens up, closes, opens up, closes, opens up, closes, opens up, closes. And so what that's doing is that whenever the clutch opens up, it is allowing lead from the pencil to fall via gravity through that clutch and extend, and then the clutch grips it again so that you can have it stable so that you can have a great writing experience. Now, the clutch is not a foolproof mechanism. I mean, it's an elegant piece of engineering that, like any form of engineering, has its limitations. And so one thing that we can do to sort of frame this discussions is what sort of problems do you get with the clutch of a mechanical pencil, no matter what material that clutch is made out of. First problem is jams, and I did a video about unjamming mechanical pencils. Jams are caused whenever you get a buildup of dust, or if there is a misfeed for the lead that results in more than one stick of lead trying to feed through at once. Go ahead and watch that video if you are interested in how to clear mechanical pencil jams. I will put a link to that in the description. So jams is an issue that can happen with the clutch. Second big problem that you get is lead slippage, also related to the clutch. If you are using a much harder lead, like leads in the H range, like 2H or 4H, those harder leads are difficult for any clutch to hold on to, because you're less likely to be able to get that clutch to dig into the lead on a microscopic level so that it can hold on to it. And so dust can get in the grooves of the little teeth of the clutch and prevent those teeth from gripping onto the stick of lead, just like if you were driving in heavy rain, or if you were to get a lot of mud inside your tires or ice and snow inside the grooves of your tires, and then your tires start spinning in the winter. That would be an example the same way that you can get slippage, because all of these things are reducing the friction between the object and the ground in the case of a vehicle, or between the clutch and the lead in the case of a mechanical pencil. And then the final issue that is also related to the clutch is internal lead breakage. And I'm not talking about lead breakage when you're writing with the pencil, like if I click out some lead and then press hard, that's lead breakage on the outside. I'm talking about lead breakage that happens internally when you drop a pencil and you find that there is a tiny little stick of lead, maybe about this long, that you're having difficulty advancing through the pencil because the clutch would be located right here. And the clutch is almost always where that lead snap is going to occur, because that is where there is pressure being put on the lead. It is being gripped by that clutch. And so it is at that location right there that you are most likely to get internal lead breakage. And especially when you drop a pencil, you'll get a little bit of jar where that clutch is, and it can result in more internal lead breakage. Now, different clutches are made of different materials, and depending upon what material you have, that contributes to these problems happening with the clutch. And so there's two main materials, and I had a little external lead breakage there. So what are the two main materials that is in a clutch? First would be plastic. It's cheap. You can injection mold it. Companies choose it because they can save on production costs. And then there is brass, which is a metal alloy that is a little bit more expensive than plastic. It's harder to work with, but it results in a better mechanical pencil clutch. Why, though, is the big question. Well, let's talk about some of the disadvantages of plastic clutches so that you can begin to understand why I keep raving about mechanical pencils that have brass clutches and more concerned about mechanical pencils that have plastic clutches. So what are the disadvantages of plastic clutches in mechanical pencil? Well, the first disadvantage is that plastic does not grip the lead as well. An extreme example of that would be trying to pick up something with plastic tongs versus metal tongs if you really need to grip it, or better yet, like plastic tongs versus pliers. We all know from experience that if we want to get a good grip on something, a solid grip on something, having steel pliers is going to give us a stronger grip than if you have plastic tongs. So if I wanted to lift something and all I have is some plastic kitchen tongs, I know that I'm not going to be successful with that. If I really need to grip it, I'm going to find a pair of pliers. Same idea behind a plastic clutch. A plastic clutch is not going to grip lead as well as a brass clutch. Another reason for that is that when you injection mold plastic, there is only so fine of a detail that you can get of the grippy parts of that clutch in order for it to still grip. In other words, you are limited by workings of the material itself and what you can injection mold. Versus machining a brass clutch, you're much more likely to get fine tooth details of that brass clutch. Now, I'll be honest with you, I've never dissected a plastic clutch versus a brass clutch. That might be a video that I'll want to do sometime in the future in which I fully disassemble a pencil that has a brass clutch versus a plastic clutch and see if we can zoom in on it with the camera and see if there are any noticeable differences between the two. But plastic in general is going to have that advantage of not being as fine of a material to work with and not be able to grip the lead as well. And anybody who uses a mechanical pencil with a plastic clutch knows that this is a liability of that pencil. Plastic is going to hold onto lead dust easier than a metal pencil clutch will. And that has something to do with the triboelectric series. It's a principle of electrostatic attraction that I'm going to talk about in a few minutes for those of you who are interested in the science of this. But for right now, we're just going to nail down the disadvantages. One of the disadvantages of plastic is dust tends to stay electrostatically attracted, and then you're more likely to get lead slippage and lead jams as a result of that. And then finally, plastic is more subject to bending and jostling whenever you drop a mechanical pencil. And so this is going to increase the chances of internal lead breakage, which I discussed earlier being a problem in general with the clutch. If I drop a pencil with a plastic clutch on the ground, usually the pencil is going to be generally not as well manufactured as compared to a pencil that has a brass clutch anyway. They tend to go together. Better pencils tend to have brass clutches. Economy pencils tend to have plastic clutches. And so whether it's just the plastic clutch itself or whether it's the general construction of the pencil that allows the lead to move around and have pressure set on it, like we talked about in this little diagram up here, you're much more likely to get internal lead breakage with plastic. Okay? So what is it about this holding on to dust easier that is an issue? Let's talk a little bit about the science of electrostatic attraction. So there is this principle in electrodynamics called the triboelectric series. And basically what the triboelectric series is a rating scale that rates different materials on how likely they are to hold an electrostatic difference, a charge separation across them. And so if you've ever done the thing where you've taken a blown up balloon and you've rubbed it on a piece of clothing or your hair or a piece of wool, what you are doing is you are stripping electrons off of whatever object you're rubbing the balloon on. And when you have a large enough charge separation between a surface and the balloon, which has extra electrons, those electrons, remember, opposites attract and like charges repel, will tend to push the electrons farther into the object, leaving more positive charges, a charge separation across the surface, and that's why this balloon sticks to that surface. Now, that doesn't just apply to balloons and surfaces. It also applies to lead dust, a combination of graphite and clay, and the clutch of a mechanical pencil. So in the triboelectric series, there are certain materials that do not hold a charge separation. Steel does not hold a charge separation. And we all know this from personal experience. Whenever we walk with stocking feet on a carpet and then touch a steel doorknob, you're more likely to get an electrostatic discharge which is a fancy term for a shock, from that steel doorknob, because steel does not like to hold a charge separation. There are other materials that are much more likely to hold a charge separation, like plastic is a common one. Okay, human hair can hold a charge separation. Okay. And so the triboelectric series rates different materials on how likely they are to hold that charge separation. Well, spoiler alert, you've probably been able to figure this out at this stage. Plastic holds a charge separation, and brass is much less likely to. So the reason why a brass clutch is less likely, part of the reason why a brass clutch is less likely to get jammed is that any of the dust that is present inside the internals of a mechanical pencil that has a brass clutch, they are less likely to be electrostatically attracted to that brass. In other words, they'll be more likely to fall out through the lead sleeve of the pencil onto the paper, making it less likely that you will get a lead jam. That does not happen with a plastic clutch. A plastic clutch is much more likely to hold that charge separation, electrostatically attracting that lead dust to the internals of the mechanical pencil, and then it builds up and it builds up and it builds up, and you're more likely to get lead slippage, you're more likely to get it jamming up the mechanism. There's all sorts of problems that happen as a result of that issue. And so triboelectric series explains why there is this charge separation that becomes the enemy of mechanical pencils if you have a plastic clutch. Brass doesn't do that. So brass actually serves two functions. Brass is not only sturdier than plastic, but since it is much less likely to hold a charge separation, you do not get as big of a problems with dust causing jams, causing lead slippage with that brass clutch. Okay? So there's a little bit of the science behind the difference between brass and plastic in terms of its functionality for a pencil. Now, we haven't talked at all about what brass is, and so I'd like to do that at that stage. So the big question is, what is brass? Well, brass is a metal alloy. An alloy is a combination of two or more metals that when you arrange those two metals, the atomic structure of those metals, the crystalline structure, is usually stronger than either metal on their own. Okay, so a common example of a metal alloy that you may be familiar with is that there's an entire age of human history that was named after bronze. Bronze is a combination of copper, the metal copper, and the metal tin. And based upon the ratio of copper to tin, during the Bronze Age, humans were able to produce a metal alloy that was much stronger than either metal on its own. And anyone who has worked with copper or tin knows that one of the big advantages of copper, in addition to it being able to conduct electricity really, really well, copper also bends very easily, and so it's really ideal for us for wires in houses. And then if you consider tin is also a much more malleable metal, but when you combine the two together, bronze is a lot stronger as a metal alloy than copper or tin alone. And then we can also compare it to brass, which is what most metal clutches are made out of. Brass is a metal alloy of copper and zinc. Okay, so a proportion of copper and zinc. And my apologies if you can hear the dogs howling. Not much I can do about that right now, and so we're just going to have to power through on that until they tire out and stop barking. I'm the only one who's home right now, and so they're going to have their little bark fest until I get back upstairs. So brass is the metal alloy of copper and zinc. Now, interesting historical aside for this one that some of you might be interested, especially if you follow archaeology. The British Museum has obviously been doing a lot of work into antiquities for many generations. And I read recently that the British Museum, and I'm sure many other archaeologists have started using the terminology copper alloys when referring to engineered human pieces of engineering of humans from the past, because what they've discovered is that most people in the past, when they have written about either bronze or brass, they haven't really understood the difference between the two when they were writing about them. And so what has happened is that you'll have somebody writing about a bronze sculpture, and they'll, in modern times, will get a hold of it and will realize this is not bronze, this is brass, and vice versa. And so we have this problem with ignorance of writing about these metal alloys in the past. And so they've now decided that instead of referring to something specifically or about bronze or brass, if they don't know about it, they will just refer to them as copper alloys if they have not done a metal analysis, because they cannot trust that what the person in history wrote about was actually bronze or actually brass, because they've uncovered a lot of mistakes that people have made. Okay, so brass has this advantage of being much stronger than plastic, and therefore much more likely to be able to grip the lead securely. Which, if you have a really great clutch securely gripping the lead, you are less likely to get internal lead breakage. I'm not going to tell you that you're not going to get any internal lead breakage, because when you drop a mechanical pencil, that's quite a jar. And to some extent, whether you have plastic or brass, you're risking internal lead breakage no matter what you do. But it is a clutch that is going to be much more likely to survive a drop in that regard. In addition, the teeth of a brass clutch are going to be more defined, perhaps deeper grooves, and therefore they're less likely to fill up, so to speak, with lead dust. And combine that with where brass sits on the triboelectric series, it does not hold a charge separation very easily. Any of that dust is more likely to fall out of the pencil than stick around. So yay! Brass clutch. Okay. Static electricity is the enemy of mechanical pencil lead jams and lead slippage. We don't want that dust inside the mechanism, and brass is going to be more likely to prevent that dust from causing jams or lead slippage for that wide variety of reasons. Now, I brought out two pencils today to sort of highlight what some of the key differences are, because I think it might help you to understand why I spend so much time ranting and raving about whether or not a pencil has a brass clutch versus a plastic clutch. And so let's take a look at the Papermate Clearpoint, available virtually anywhere in stores. Let's unscrew the tip. And the more I unscrew the tip of a Papermate pencil, the more likely these pieces are going to break, because this is not a very well manufactured pencil. Now you'll notice that the outer parts of the pencil, there are brass pieces inside of a Papermate, but it is not the clutch itself. Okay, the clutch of a Papermate Clearpoint is a plastic clutch. Okay, and so when you click the top of the pencil, and I can't do it right now because resistance of the tip of the pencil is necessary in order to extend out the clutch. Oh, let me give it a try here, since it is side advance. No, the side advance won't even work at all on these when you do not have the tip screwed in. So when you open this up, the three pieces of the clutch open up, allowing the lead to move. But since the Papermate Clearpoint is made from clutch is made from plastic, there's a couple things that you're going to notice. One, the lead extension on a Papermate Clearpoint is going to be a lot of lead on very few clicks, because you have much less fine control over the lead extension with a plastic clutch as compared to a brass clutch as well. That's also another difference between the two. and we can compare that to another economy pencil, the Zebra Hand Fit, we have a little bit less lead extended, and you can see that I had a little bit of internal lead breakage here despite having a brass clutch because I was moving these things around. And so these things definitely can happen. But as I feed a new piece of lead in there, this brass clutch from the Zebra Hand Fit is going to last a lot longer than a Papermate Clearpoint. And I'll be honest with you, I see students getting frustrated with Papermate Clearpoints all the time. And I understand why they have them. They're cheap, and it still allows you to have a mechanical pencil, and they have this nice little twist-up eraser that allows you to get a lot of erasing in before you have to refill an eraser. And they have, a fluted grip with a rubber piece on it. It's retractable lead sleeves, so it's pocket safe. I understand why students like the Papermate Clearpoint because of all those other features, but for me, since it has this plastic clutch, it's more of a liability than anything in terms of the pencil lasting for a long period of time. Now, the Zebra Hand Fit is also an economy pencil. Okay, there's a lot of issues with this pencil as well in terms of its overall ability to survive over a long period of time. But with a brass clutch, the clutch is less likely to become the problem, less likely to give you jams, less likely to give you lead slippage. And so there we have it. Why is a brass clutch so special in a mechanical pencil? Well, there's a host of reasons. In summary, metal alloys are much stronger. They're much more likely to grip the lead without breaking it internally. A brass clutch, being a metal alloy, is an aspect of that on the triboelectric series is that it is less likely to hold a charge separation, and as a result of that, you get less electrostatic attraction between mechanical pencil lead dust and the clutch, and that means fewer jams, and that means less lead slippage. And so there's all sorts of advantages to a brass clutch as compared to a plastic clutch. For the average user, maybe that's not going to make that big of a difference for you. Maybe mechanical pencils are more disposable for you. But if you are an enthusiast who wants to know why you seem to be getting better performance out of a brass clutch versus a plastic clutch, those are some of the scientific and engineering reasons why there's a difference between using those two different components of the internals. I hope you enjoyed this video. This is part of my series of science and engineering of mechanical pencils, and I have a whole bunch more pencils to review on the channel coming up, including the Zebra Hand Fit. I'll go ahead and do a review of this one coming up. I also have several other mechanical pencils coming up, including the Pentel Technica X, a vintage mechanical pencil coming up on the channel. So thanks for watching. Feel free to leave a comment below if you have a question. Feel free to make suggestions, although I just want to remind everybody that I have a long list of mechanical pencils to review, and I'm doing this for me, and so I prioritize different videos according to what I feel like at a different time, because this is supposed to be a stress reliever for me. And so, but that doesn't mean that I don't want you to comment and that I don't want you to give suggestions. I don't purchase every pencil that people make suggestions on. The reason for that is that I don't have unlimited funds, and I always have to make an informed decision as to whether or not I think I'm going to get use out of mechanical pencils that I purchase. I don't just purchase mechanical pencils to collect. I purchase pencils that I'm going to get some use off of. So consider those things as you're leaving comments. You're more than welcome to do so, but those are sort of the governing principles that I operate under for this channel and for working towards adding things to my mechanical pencil selection. So thanks again for watching. Hope you have a great day, and happy May.